our agenda. So, to understand that WebAssembly is a game changer, let's understand what is the game. So, before WebAssembly or right now, there are some problem in web like performance issues. There are many simulation softwares or games which are built for native platforms like on which can run on native hardware, but not on a web. So there is a problem that web apps are much slower, no, not much slower, but pretty much slower than the native applications. So this is why we need performance for like gaming, AR, VR, video editing, simulations. These are some pretty much things which we need performance for. And another one is cross-platform compatibility. Suppose you write a code in, let's say Python, you have to compile it for two different operating systems or two different processors, type of processors. So there is a issue of that cross-platform compatibility. And another one is browser limitations, which is very close to my heart. I was working on a project, and suddenly I didn't know that Safari doesn't support a time input, and I just created a time input and showed to the client, and then client saw that, and it was not working on their machine. I am only sole user of like Chrome and all the Android and Windows system. I have not touched iOS. Still my okay. So that's the browser limitations. And also there is a lack of JS libraries. You may don't know, but there are like some things which are available on normal, like let's say C, C++, Go, but not these libraries are available on JavaScript. These are pretty much the problems, and so we understood the game. Let's understood the game changer, and so no point for the guessing. WebAssembly, aka WASM. So if you go to the webassembly.org, you will see this definition. Let me read it first. WebAssembly is a binary instruction form. Okay, ignore that. So they are saying it. Just understand line by line, and through this, I will continue my presentation. WebAssembly is a binary instruction format for a stack-based virtual machine. Okay. So everyone knows that browser has web APIs and JavaScript engine. Web APIs in the sense DOM and fetch. For of now, just consider them two. So JavaScript engine can talk with the web APIs, but still it won't interact with the processor, because JavaScript engine is built for a specific purpose, not for to run on any processor. So here comes the WebAssembly, which runs on a stack-based virtual machine. I will explain stack-based virtual machine after this. So, and WASM can react with WASM can interact with the JavaScript engine, and through JavaScript engine, he can interact with the DOM. So this is the right diagram. So here you can see WASM runs in a stack-based virtual machine, which is a sandbox environment where WebAssembly runs. And the sandbox environment is designed very close to the processor, so that the latency is very low. Unlike JavaScript, it is a different architecture basically. So that's what makes it more performant. WebAssembly is more performant than JavaScript. So you may be wondering, what is stack-based virtual machine? Anyone from Java background? Java. Okay, there is another one also. Okay, so in Java there is a JVM called Java Virtual Machine, very similar to WASM. Java Virtual Machine is also a stack-based virtual machine, and where your all code runs, and it is independent of a platform. So it follows the right one and use anywhere rule. Okay. So I know I wrote this like I made this PPT last day, and I don't know how to serve you guys. So I just added few questions, and with this, I will try to explain what is WebAssembly. So you might be wondering that do I have to learn WebAssembly to use in my project? Anyone wondering that? No, no, thanks. So here's the answer: that do you write normal assembly code in day-to-day basis? You write code in C++ or any other low-level language, and then you compile it into web assembly, and the assembly codes then create some machine code. Similar to the web assembly, we don't have to create, like we don't have to write the web assembly. There are some compilers like yes. So let's suppose there is a library in C++ and you want to use it in JavaScript. You can take the C++ code, compile it into the WebAssembly, which is we call it porting, and then WebAssembly is also available in your window. In syntactical. Okay, it can be anything. Not but there is a window object provided by the JavaScript. In this you will get a WebAssembly object, and through that WebAssembly object you can interact with the WebAssembly. So here's the basically flow of it. Okay, so you understand how we can port the C++ code into the WebAssembly. But do you have to learn C++ or Rust in this case? Because we are web developers, we know JavaScript well, and we don't want to change our stack. So do we have to learn C++? And the answer is no, and depends, because there are many libraries such as FFmpeg, OpenCV, and TensorFlow there. They are already ported into the WebAssembly. So we actually don't have to do this boilerplate code work. We can just use their JS version and implement in our websites. Another problem you may remember that I said about cross-platform compatibility. So here it is. I was an Android developer and I know about this. So you have to like Kotlin only runs on. Kotlin is developed for Kotlin used to be a language for Android. Before it was Java, and then then it is Kotlin, and then it came KMM, which is Kotlin Multi-Platform Management, which serves through which you can share your business logic from iOS and Android both. And but there was a problem that you can't use this business logic to the web platform. There was options like there was a Kotlin JS which transfers your Kotlin code to the JavaScript and then runs as a JavaScript code. But through WebAssembly, we can compile entire Kotlin code, only business logic, and then we can run it on Android, iOS, and web individually, without having to port anything, like rewrite the entire thing. And here's the very famous case study about Figma. If you go on Google and search about Figma's WebAssembly case study, you will find one that WebAssembly cut Figma's load time by 3x. You are seeing this black portion is designed in React, and the white portion is WebAssembly code, which is it's a canvas which is rendered by the WebAssembly. So WebAssembly comes into picture where you have some specific requirements about the performance. If you compare it with JavaScript, WebAssembly and JavaScript both are equal, but in terms of memory management, WebAssembly gains some difference. There is another one called goodnotes.com. I don't know what it is, but I saw the case study, and GoodNotes is basically used in iOS devices where you can create some good notes, I guess. Okay, so it was like 10 years before they created the good notes, and it was written in Swift. And now they want to go to the web platforms, and like basically they want to reach to wider audience. So they choose WebAssembly and ported their entire Swift code into the WebAssembly, and now they are using the core business logic in web, which is more like it cut down their more efforts by not rewriting entire code into JavaScript. Again, that's it. I know it is too early, but do you have any questions? If no, I can ask you. Okay. So wait. By the way, what do you guys think? WebAssembly can replace JavaScript or not?